Hello, everyone. So, this is the second part of our discussion on the topic angles in a unit circle. So, here we will be discussing the length of an arc in a circle, which corresponds to the linear measure of the arc in a circle. So, from that, we will now know the relationship between the linear and angular measures of arcs in a unit circle. Then, after that, we will apply those concepts that we are going to learn to solve the area of a sector in a circle. Okay, so let's have now the length of the arc in a circle. Okay, so let's recall that if the length of the intercepted arc by the central angle theta in radians is s in a circle with radius r, then r is equal to s over theta. This implies now that S is equal to R times theta. S is the arc length, R is the radius, and theta is the angle in radians. So this is now the relationship between the linear measure of the arc in a circle, which is this S, our arc length, and theta is the angular measure of the arc in a circle. So that is in radians. So we have this relationship S is equal to R times theta. Okay, now let's apply this one in solving problems, okay, involving arc lengths and angles in a unit circle. Okay, so let's now have this problem. So we have here two problems. So let's answer problem number one. Find the length of an arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. So for number one, let us first write the given values. So we have here given. First, we have the radius, which is 10 meters. So r is equal to 10 meters. And we have the measure of the central angle, which is 30 degrees. So theta is equal to 30 degrees. And we need to find the length of the arc, and that is your S. And that is equal to r times theta. Okay, but take note, our theta here should be in radians. Okay, but what is given is in degrees. So we need to convert first this 30 degrees into a radian measure. Okay, so converting this one, we will just multiply this by pi over 180. And we will now have pi over 6 or pi over 6 radians. So our theta now in radians is pi over 6. So we can now solve the problem using the formula. So S is just equal to the radius, that is 10 meters, and multiply it by our angle pi over 6. And this is just equal to 10 pi over 6 meters, or just 5 pi over 3 meters. So this is now the answer for this problem. Okay, for number 2, we have here a central angle theta in a circle of radius 4 meters is subtended by an arc of length 6 meters. We need to find the measure of theta in radians. So the given values are the following. First, we have the radius 4 meters. So r is equal to 4 meters. And the length of the arc is 6 meters. So we have S is equal to 6 meters. We need to find our angle theta, and that is just equal to S over R from our formula, right? So applying the formula and doing direct substitution, we will now have 6 meters over 4 meters, since our S is 6 meters and our R is 4 meters. So from that, we will now have 3 over 2. Okay, so therefore, our theta in radians is 3 over 2, or 3 over 2 radians. So you can just um, omit radians. So if the angle has no unit of measurement, it is already understood that that is in radians. Okay, so we can now have 3 over 2. Okay, so that answers our problem. And given the radius and the angle theta, we can actually solve for the area of a sector in a circle. So we will now apply these concepts in solving the area of a sector in a circle. So what is a sector? So a sector of a circle is the portion of the interior of the circle bounded by the initial and terminal sides of a central angle and its intercepted arc. For illustration, we have this one. This gray region here is actually the sector of this circle. Okay, so if a central angle of a circle has a measure theta radians, then the sector makes up the fraction theta over 2 pi. Why is that? Take note that um, this sector has the angle theta radians, and the whole circle, one full circular rotation, is just equal to 2 pi radians. So that portion now is just equal to theta radians over 2 pi radians, or just theta over 2 pi. That's why the sector makes up a fraction equal to theta over 2 pi. Okay, so that is theta over 2 pi of a complete circle. And the area A of a sector is given by, we have this formula. So A is just equal to theta over 2 pi times the area of the circle. Since theta over 2 pi is just the portion, so to find the area, so we need to multiply the whole area of the circle by that portion, right? So we have theta over 2 pi times pi r squared. Okay, and that is just equal to 1 half theta r squared. So our pi here will be canceled out. Okay, so we now have the area of the sector is equal to 1 half times theta r squared. So we need the angle theta and the radius to solve for the area of the sector. Okay, so to apply this formula, let's consider these examples. Okay, so for number 1, we need to find the area of a sector of a circle with central angle 60 degrees if the radius of the circle is 3 meters. So what are given here for number 1 are the following. The central angle is 60 degrees, so therefore theta is 60 degrees. And the radius is 3 meters, so r is equal to 3 meters. Okay, and we need to find the area of the sector, and that is equal to 1 half theta r squared. But take note again, theta should be in radian measure. So we need to convert 60 degrees in radian. So that will be, so we will just multiply 60 by pi over 180. And that is equal to pi over 3. So therefore, our area now will be equal to 1 half times theta, which is pi over 3, multiply it by the radius 3 meters. And we have square. So from that, this will now be equal to, so 3 meters squared, so that will become 9 meters squared divided by 3. Okay, so that will become 3. And multiply it by pi, so we have 3 pi over 2 meters squared. So this is now our area. 3 pi over 2 square meters. Okay? So for number 2, we have here a sprinkler on a golf course fairway is set to spray water over 70 feet and rotates through an angle 120 degrees. Find the area of the fairway watered by the sprinkler. So what are given here are the following. First, the sprinkler sprays a water over 70 feet. Therefore, yung span ng water na naaabot ng sprinkler is 70. And the sprinkler now it corresponds to the center of our circle. So from that, 70 feet is actually the radius of our circle. So R here is equal to 70 feet. Okay? And it rotates down through this angle 120 degrees. Therefore, our angle theta is equal to 120 degrees. But take note, angle theta should be in radians, so we need to convert this one. So 120, multiply it by pi over 180. And this is just equal to, we have 2 pi over 3. Okay? And we need to find the area. Okay? And that is equal to 1 half theta r squared. Okay, applying. So we will just do direct substitution here. So we have 1 half. Multiply it by 2 pi over 3. And we have 70 feet square. And this will now be equal to 70 feet. So 2 pi over 2, this will be canceled out. 70 squared is 4,900, right? Pi over 3 feet square. So this is now our final answer. So that ends our discussion for this lesson. Thank you for watching.